Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone, welcome to lecture 6, Organic Chemistry 1. Today you will learn how to draw chemical structure in a correct way. We have studied already how to do Lewis structure. We have Lewis structure, we have condensed structure, and we have linear structure. The first question, draw the Lewis structure for the following condensed structure. This is a condensed structure. So the first step, you make a connection between all the atoms except hydrogen. So we have here carbon carrying 2 CH3. So that's CH3, CH3. And then this carbon connected to oxygen. All right. This oxygen connected to carbon. Okay. And this carbon connected to carbon. So this is the first step. The second step is to draw the CH bond. Okay, that's carbon carrying 3 H's. And so on. But do not forget to add the lone pair on oxygen to complete the Lewis structure. Lewis structure is time consuming. So chemists look for a better way to present the chemical structure, and they came up with what we call it line structures. This is benzene in Lewis format. Carbon connected to carbon, connected to carbon, 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 5 carbons. Carbon, carbon is one line, carbon here and carbon here. So we continue until we reach 5 points. That's it. Very simple, straight way to draw benzene. When we have double bond in the condensed structure, we write 2 lines. And since these carbons are sp2 hybridized, this means that it has 3 sigma bond in the shape of trigonal planar or trigonal planar. And since we have 2 CH3 here, 2 CH3 there, the structure, line structure, will be that one. If we have acetone, this is Lewis structure. We have to add the lone pairs. Okay. Then carbon, carbon again, carbon, carbon, one line. This carbon has double bond O, so it is sp2. So we draw it in a way that this angle 120, 120, 120, and this is the right way to draw line structure for acetone or propanone. If we have triple bond, okay, here is carbon, and this is carbon. This carbon has CH3, so one line, CH3. This is carbon, carbon, carbon. So sp3 carbon, we make it zigzag line. sp carbon, zigzag line. Okay? sp, 2 carbons, trigonal planar. If we have sp, linear. And we are done with line structure. When drawing single bonds, the direction in which the bonds are shown is irrelevant. So you have branch, you draw it this way or that way, it doesn't matter. All heteroatoms, atom other than carbon and hydrogen, must be drawn, and any hydrogen atom attached to a heteroatom must be drawn. Here, for the alcohol, you have to show the O, and then you have to show the H. And remember, once again, lone pair must be drawn. Never draw a carbon atom with more than 4 bonds. Carbon only has 4 orbitals and its valence shell, and therefore carbon atoms can only form 4 bonds. Now, draw a bond line structure of the following compound. You have Lewis structure, and you have been asked to do the line structure. First, write the structure without hydrogens on carbon. Take these all hydrogens out. You take them out, okay, then you will end up with this one. All right? Now put the carbon and heteroatom in line. Zigzag line, zigzag line, zigzag line. Here, remember that you have a triple bond, sp carbon, linear. Here you have double bond. Remember, you have trigonal planar. Oh, this one is sp2. Then again, you have to draw it trigonal planar. You have done so? Now, once you reach to this, take the carbon out. Now you have the right geometry and everything is correct. All right? Predict the geometry for all atoms except hydrogen in the compound below. This is a compound, and بيسألك predict the geometry for all atoms. Geometry connected to hybridization. Hybridization, I get to know it from number of sigma bond and lone pairs. So keep in mind that to show all sigma bonds, so the first step is to add all carbon hydrogen sigma bond. Hydrogen, hydrogen on all the aromatic carbons. Okay? This carbon is connected to carbon. This carbon, okay, I have to add the sigma bond, carbon hydrogen. For oxygen, I have to add the lone pair. Okay, for this carbon I have to add the 3 carbon hydrogen bond. Okay, now what is the steric number of the aromatic carbons? We will find 3 sigma bonds, 1, 2, 3 sigma bond, no lone pair. So the total of steric number is 3. The hybridization will be sp2. Electronically trigonal planar arrangement of atom will be trigonal planar. For this carbon, again, bond to 3 sigma bonds. Steric number will be 3, sp hybridize, and will be trigonal planar. For this oxygen, we have 1x sigma bond, we have E2, 2 lone pairs, so the steric number will be 3, hybridization sp2. You see, we have only AX will be a linear. For this carbon, how many sigma bond? 1, 2, 3, 4. So we have steric number of 4, hybridization sp3, electronically tetrahedral, arrangement of atom will be tetrahedral.
It's time to implement what we have learned in predicting the physical properties of molecules, starting with dipole moment and molecular polarities. When two electric charges of opposite sign and equal magnitude are separated by distance, an electric dipole is established. The size of the dipole is measured by its dipole moment, mu. Dipole moment is measured in dBi units, which is equal to the distance between the charges multiplied by the charges. 1 dBi is equal to 10 to the power minus 18 electrostatic unit multiplied by centimeter multiplied by the electrostatic unit.
Carbon Cl bond has a bond length of 1.772 times 10 to the minus 8 centimeter, and an electron has a charge of 4.8 times 10 to the minus 10 electrostatic unit. If the bond were 100% ionic, then the dipole moment would be mu equal to E charge times distance. Here is the charge and here is the distance, will be equal 8.51 10 to the minus 18 equal 8.5 dBi unit. The experimentally observed dipole moment is measured at 1.87 dBi, and we can use this value to calculate the percent ionic character of CCl bond. 1.87 divided by 8.51 times 100 equal to 22% ionic character. Remember that we have carbon Cl bond where chlorine is more electronegative than carbon, so it's partially negative, and the carbon is partially positive, and we call this polar covalent bond. Carbon single bond oxygen has bond length of 1.41 angstrom, observed mu 0.7 dBi, percent of ionic character applying the same rule, mu observed divided by you calculated times 100, you will get 10% for CO ionic character. OH, bond length 0.96, observed dipole moment 1.5, and it has 33% ionic character. C double bond O, which you know that it exists in resonance structure, carbon single bond oxygen, negative on oxygen, positive on carbon. The bond length is 1.227, observed dipole moment 2.4, and it has 41% ionic character. Carbon tetrachloride or tetrachloromethane has dipole moment equal to 0. Why? Because these three hydrogen as a chlorine atom has dipole in these directions, equal to one of them, but in the negative direction, let's say X. And here is bond, carbon Cl bond, has dipole moment of equal value on the other direction, so they eliminate each other. In carbon carrying 2 Cl and 2 hydrogen dichloromethane or methylene chloride, we will find a molecule that chlorine withdrawing on that direction the electrons, so it has dipole moment on this way, and the other way it's carbon hydrogen, which is almost now, so you have direction of dipole moment this way, and we have the value of 1.14. For ammonia, you have direction of dipole moment. Nitrogen is more electronegative than hydrogen, so the dipole moment will be on that direction, on that direction. It will be equal to one of them in that direction, same value, and this will add to that, giving a dipole moment in that direction of value of 1.47 dBi unit. The same, oxygen more electronegative than hydrogen, so we have dipole moment on that direction, and these two will be equal, the same value of one of them, but in this direction you have lone pair, so dipole moment will be on that direction, equal to one of them in this direction, so they are on the same direction, so you will add them together and end up with a value of 1.85 dBi unit. In carbon dioxide, dipole carbon double bond oxygen in that direction, same value in the other direction for the other C double bond O, they cancel each other, and that will be nonpolar molecule. Carbon disulfide, which is used as a solvent in organic reactions, again, this molecule is linear and is non-polar. Intermolecular forces and physical properties. The physical properties of a compound are determined by the attractive forces between the individual molecules, called intermolecular forces. What are they? Dipole-dipole interaction, hydrogen bonding, fleeting dipole-dipole interaction. الموليكيولز بترتبط مع بعضها ببوند خارجية، إما تكون دايبول دايبول أو هيدروجين بوندينج، أو اللي احنا بنقول عليها لندن ديسبيرجن فورس اللي هي بتبقى دايبول وقتي مؤقت. Okay? Let's see isobutylene and acetone. This lacks a significant dipole moment عشان كلها carbon-carbon bonds. Here we have carbon-oxygen bond. This is a polar molecule. Okay? Acetone does have a net dipole moment. Therefore, acetone molecule will experience greater attractive force than isobutylene molecules. ولذلك لأن دي مرتبطة أكتر ببعضها هنلاقي إن البويلينج بوينت هنا 56.3 degree Celsius, while in isobutylene it is minus 6.9 degrees Celsius. There is no interaction between the molecules. Acetone has higher melting point as well as higher boiling point. Hydrogen bonding between the partially positive charged and partially negative charged species. فهنا في hydrogen bonding between the oxygen with partially negative and the hydrogen with partially positive. In water is stronger than ammonia. موجودة في الأمونيا بس هنا أقوى من دي. Okay, برضه partially positive و partially negative nitrogen atoms. In ethanol موجود hydrogen bonding between the partially positive and partially negative oxygen of another molecule. In ethanol there is a hydrogen bonding. There is a partially positive and partially negative. While in ether, methoxy, methane, or dimethyl ether, there is no OH bond. Even the whole molecule is a polar molecule. Okay? It's O, carbon, carbon, lone pair, lone pair, polarity this way, dipole moment this way, and net polarity on that way. So this is a polar, but it does not contain OH bond, right? So there is no hydrogen bonding. That's why you will find the boiling point of ethanol 78, while boiling point of methoxymethane is minus 23 degrees Celsius. Here is amine, 3 structures: tertiary amine, secondary amine, and primary amine. In the tertiary amine there is no NH bond, only N carbon, N carbon, N carbon. The isomeric secondary amine with 3 carbons, ethyl methylamine, has only 1 NH. So there is partially positive hydrogen, partially negative nitrogen. And you are expecting to have this molecule to possess hydrogen bonding. In the isomeric primary amine, propylamine, you have 2 NH, so you have higher probability of forming hydrogen bonding. That's why you find here boiling point 49, higher than secondary amine 37, higher than tertiary amine 3.5. So we have now covered dipole-dipole and hydrogen bonding. The third type is what we call a fleeting dipole-dipole interaction, London dispersion forces اللي هي الدايبول المؤقتة. بيقول لي the fleeting or transit dipole moment is directly proportional to the molecular weight. So we have hexane, higher molecular weight than pentane, higher molecular weight than pentane. Then you find that hexane has 69 boiling points, while pentane 36 and butane 0 degrees Celsius. London dispersion force are stronger for higher molecular weight hydrocarbons because these compounds have larger surface area that can accommodate more interaction. Accordingly, when we have isomeric structures of alkanes, pentane normal, and if you have 2 methyl pentane, one more branch, and you have 2,2-dimethyl propane, more branched, less surface area for interaction. Here is 10 degrees Celsius boiling point, 28, and here is 36. Since this straight chain alkane has more surface area to interact. A branched hydrocarbon generally has a smaller surface area than its corresponding straight chain isomer, and therefore branching causes decrease in boiling point. تعالوا ناخد سؤال. Determine which compound has a higher boiling point, new pentane or 3-hexanol. The checklist we are going to make a comparison is, are there any dipole-dipole interaction in either compound? Dipole-dipole. There is no dipole. It's almost like dipole. Here we have OH. We have partially positive, partially negative, and the whole compound is polar, right? So we have dipole-dipole. Yes, we have in B, but we don't have in A. Will either compound form a hydrogen bond? Yes. This one will have hydrogen bond. Yes. This compound does not. Okay. How many carbons? I'm looking for the molecular weight. Okay. This is C5 and this is C5. Okay. But here the molecular weight, of course, higher because of OH. Okay. How many branches in each compound? Okay. The branch in here more than in here. Okay. And remember, the branching decrease while this increase, while this increase. Okay. So conclusion, 3-hexanol has a higher boiling point. 3-hexanol has a higher boiling point. Solubility. Solubility is based on the principle that like dissolves like. If an article of clothing is stained with polar compound, the stain can be generally washed away with water, like dissolves like. However, water will be insufficient for cleaning clothing stained with non-polar compounds such as oil or grease. In a situation like this, the clothes can be cleaned with soap or by dry cleaning. الصابون أو الصوب بيتكون من long chain hydrocarbons اللي هو non-polar و end up with carboxylate ion. الكربوكسيليت polar part، يبقى عندي polar part وعندي non-polar part. ايه اللي بيحصل؟ ان الديرت اللي هو النون بولر هيجي عليه حبيبات او الجزيئات بتاعه الصابون اللي هو الجزء بتاعها اللي هو الهيدروكربونز الطويل اللي هو النون بولر. يبقى الديرت will be dissolving in non-polar part of salt molecules. النون بولر بارت هيبقى هو موجود في الاوتسايد ريجن اللي هو بعد كده انت هتشطفه بميه، فالميه لانه ده نون بولر مع الووتر بولر هياخدوا ايه؟ يبقى المايسلز دي اللي اتكونت، المايسلز اللي اتكونت هتتحرك وتمشي ايه مع الميه وتسيب الايه؟ النسيج. رايت؟ ده بالنسبه للاكشن بروسيس بتاعت الايه؟ الصوب. For dye cleaning it is the same. If we have molecule like this with dipole moment zero, it's non-polar, and with low boiling point, the tetrachloroethylene or ethene will be a very good choice for dye cleaning. Okay? And again, we are not going to use any water in here, just this solvent. See you in the next lecture. Bye bye.